back to another spaceexplr episode. Today we have a very special guest on. And for a lot of ladies who want to get involved with space and robotics and space engineering and a lot of different things, because we're going to be covering a lot of different topics. Ladies, this episode is for you. So make sure to watch this and get a ton of inspiration and knowledge about space. And today's guest is NIKOLA Bukowiecka. So NIKOLA is 23. She's from Szczecin in Poland. She's currently in her second to last year of master's degree in physics at the University of Szczecin and a third year student of automation and robotics at the University of Technology. Her goal is to be involved in creating the technological progress, and she hopes she will do it by working in the fascinating space industry. And of course, there's all these social media links going to be linked below, which Instagram, Facebook, LinkedIn. So again, make sure to follow up with NIKOLA after this interview is over and make that connection and ask those important questions about space and exploration. So NIKOLA, for you personally, thanks again for coming over today. I really appreciate it.
Thank you. It's an honor to be here.
Thank you, thank you. It's my honor again to meet you and make this happen and bring more attention to what you're currently going through and why space should be important to people as well. So again, you currently, as you mentioned before we started recording, is you're still going through your master's degree in physics. So can you talk about your personal kind of background and decision-making process? Why have you picked physics in particular?
I think it started off when I was just a kid. I mean, I was always very curious kid, I like to ask questions about how is it working, what is it made of, and how is it all happening. And simultaneously, I think I was always good at math and some more, science-related topics. And it kind of all came together in, I think, gymnasia or high school when I discovered physics and was okay, this can answer a lot of questions that I have. And this also has this huge, room to breathe. You can develop some new things, you can create some new theories, you can research, you can do this and that. And this is something that I'm finding myself really comfortable in because you can explain a lot of things, but a lot of things are still yet to be discovered. And yeah, I think I would want to be a part of discovering something on making some theory happen or sending something somewhere and getting some sample and answer at least one of the remaining questions about the universe or the space or anything really. I think I'm a researcher.
That is good. That is good.
So
So again, from your personal, because we as kids, we grew up, and let's say when we're boys and girls, doesn't matter. When we're 7, 8, maybe 6, 5, small, right? Everybody talks about, oh, I want to be a doctor. I want to be a lawyer. Maybe not a lawyer, a doctor, a fireman, and then I want to be an astronaut. You know, it's like always one of those things is I want to
yeah.
be an astronaut. But a lot of people when we started growing up, we forget about these things. And it's like, oh, I have to work and pay the bills and do all these things. So again, for the people who are watching and maybe they're in 20s or in 30s or 40s or 50s, what will be your personal message? Why people should come back to that? Oh, we want to be involved in space exploration type of projects.
When you work in this industry and you have a passion for it, you have a big privilege, meaning you can work and gain money and some finances. And apart from that, simultaneously, you can live your dreams. So it's kind of a perfect match. Everybody should work in the place that they feel comfortable in, that brings them joy, and you feel full. And yeah, this is why I recommend that if you're interested in space and you want to research and do that, this and that, it's a perfect place for you because you can really gain some profit, not only like for you as a person, but also you can live of it.
Yeah. Okay. So talking about the research, because I mean, there is a lot of different information and the websites and podcasts just like this one and YouTube accounts and everything. There's a lot of it, right? We live in an information age right now. So what would you say from a personal experience would be kind of best places to go for people to educate themselves, do a little bit of research about space? And again, maybe you can direct them. What will be kind of a good point for them to start? Should I go and learn about space engineering? I mean, how do you go about making those decisions?
I think you should have some knowledge background. It's kind of important because if you want to dive deep into research, let's say, you, of course, it's important for you to be passionate about it, but you should have some knowledge. So I personally would recommend to go to university and finish the course in maybe physics or some engineering, or depending whatever you want to do, because uh, it's not like in the university you gain all this professional knowledge. It's not like that. We often say as physicists, I don't know, I think that when you finish a course, you have this basic knowledge of everything in physics. I mean, everything they taught you, but every basic phenomena. It's not professional knowledge. Then, if you want to pursue something deeper, you have to study more. And then comes in the internet and the literature. So, sure, there are a lot of literature that you have to or should read because it's really interesting. It's not only like equations and deriving and theorems and stuff. It's more popular science, and this is interesting and this is very useful. And also, you have internet, so every article, every drafts, every abstracts. I mean, we live in such era that whenever somebody is making a discovery, they post it online. So you can find it even for free. There are a lot of open resources when you can find it, and YouTube channels. I mean, like yours. You want to find out about how to become an astronaut, on how to be a physicist and physicist girl and stuff, you go to this channel and look it up. So don't be afraid to type even the simple phrases like what is a black hole and how to do this and how to do that. Everything is there. You have to always, make sure that you're listening to the facts, not to someone who is imagining this, and be sure to distinguish the theories and the facts, because it's easy to manipulate when someone doesn't have this academic knowledge. And even for me, when I do have some academic knowledge, when I go off to the internet and research, you have to make sure twice that it's facts, not theories.
Yeah, and it's not somebody else's opinion,
Yeah,
which there is a lot of that happening as well. No, that is awesome. That
yeah.
is a very good advice. So thanks for that. So again, it was one of the topics to mention that it's worth a talk about. Again, it's black holes, and of course we can talk about that. But one thing that I wanted to ask you, because I came across this article which was on NASA's website 2013, and I'm sure there's a lot of people who came through that personally, maybe at some point, or maybe they're looking at it right now. And we're talking about 2036 event, which we're talking about Apophis, the closest ever kind of Guinness World Record approach to Earth. So have you heard about that personally yourself so far?
Yeah, I did, but you cannot be always interested in everything.
Yeah,
So I do not know the specifics. I mean, I've heard about it, of course, because it was a world event, but
yeah,
I focused more on, as you mentioned, maybe black holes or some this new exoplanet that was found. Not
yeah,
specifically on that, because this is also something that you and everyone interested in space and science has to remember. If you want to be good, like really good at something, like be the top world or top national and stuff, you cannot really be interested in everything. This is sad, but this is true. If you want to be good at something, you have to focus on that one
so true.
thing. After you get some part of knowledge about everything and understand basics of everything, you have to focus on one thing. You cannot do like, oh, maybe I'll do this and this and that and focus on those three things and be best in everything. Though it's not true. There are a lot of people who spent 20, 30 years in some industry and they are experts, but you have to really focus on something.
That is very good advice right there. So as far as I wanted to ask you about the asteroid is because I know again you're in physics and you're a little bit in robotics as well. So I wanted to ask you, what do you personally think as NASA is talking about, let's say, deflecting this asteroid some way again through probably sending some probes that will deflect that, or maybe applying physics and doing some, I don't know. So what is your personal take? I mean, when it's comes to tackling these type of problems, let's say we have an asteroid coming to us, what do you think would be kind of the solution? Just your personal thoughts of getting rid of those problems.
Okay, so I think that there are many systems that are watching asteroids and the planets and how they're moving and stars and everything actually in space, just for not only for the defense purpose, but for the research purpose. So I think if there would be a problem of some asteroid like coming too close to us, then the whole physics and engineering world would, gather around and talk about how to deal with that. And I think there are a few approaches we can take. The first thing is we should maybe try to tackle it off at its course, because when asteroid or anything really is coming toward us, it has its course. It's like a road path it takes. So it's not always about destroying this, because this could be really hard, and we are obviously talking about a like object that will not burn itself in the atmosphere, just comes straight to earth. And we shouldn't think about maybe destroying this object, because it may be too difficult to do, but maybe tackling it a bit off the course so it changes, and then the atmosphere, the gravity will do the rest. It will just go into space. How do you have this velocity that is needed to escape the earth? It's not about the altitude, it's about the velocity. So when you have an asteroid coming towards us, you can maybe try to hit it, and or maybe not hit it with some object, but with some field, or what I mean, some flux, and then try to tackle it off. So it goes back
Yeah.
to space where it came from.
Nice, nice, nice. So thank you for sharing that, because I think that's what NASA and scientists who works for NASA and I think JPL are working towards those solutions, basically deflecting instead of as the movie, I think it was Armageddon. Remember when they was splitting the
Yeah.
drilling? Yeah. So I don't think that will happen. So talking about the black holes, because
Me
you
neither.
mentioned, yeah. So talking about the black holes, can we talk about first of all, for the people who probably heard about the black holes but they don't know, like, how does the black hole is being made? Can we talk about that process? How does that process happen?
So basically, black hole is something that we know happens at the end of the life of a star. If star is massive enough, and let's not confuse massive with big, because big, as we think of it in Earth, we have this proportion between radii and mass. If something gets bigger, it gets more massive. It's not always like that, because black holes are not made of this matter that we are aware of. It's not here, just like neutron stars or the white dwarfs. It's not the same matter we have here on Earth. So when we have a massive star and it's really, really massive, like uh, let's say 1.5 solar masses, and it's still that massive after the fuel ends, because all the stars have its like thermonuclear reactions going on, and this is the fuel. And if this fuel is like out and the star is dying and the star is massive enough, the pressure it's becoming bigger and bigger, the gravitational field is bigger, it's collapsing on itself, and we have a supernova then. And there are two ways for it to go there. We have neutron stars and we have black holes, and it's depending on mass and mass, mass, not size, mass. This is important. So if after the star has used its fuel and it's still massive enough and dense enough, we have a black hole. The star collapses on itself into a singularity. This is what we call it. We don't really know what a singularity per se is, but we think that inside of it there is a point where the space-time curvature is into infinity. This is completely absurd and abstract, and how to imagine that, I don't really know. But you can imagine like just this 2D plane going into infinity. And this is what we think happens there. So we have singularity, which is surrounded by event horizon, which is of the Schwarzschild radii. This is the physicist that discovered how big the radii is of a black hole. And then, of course, we have photon sphere because, photons are massless. The light has no mass, so it orbits around the black hole. And then we have accretion disk, which is a lot of gas and particles surrounding the black hole. And we don't actually we don't see black hole as a black hole, as we don't see event horizon, we don't see a singularity because it's black. we cannot see it. The light cannot escape from a black hole. Nothing can. And if light can't, then no other matter can. This is, kind of basic. And we do see the accretion disk. Say the accretion disk. If maybe we have some binary system, like we have a black hole and a star, and if they orbit each other, then we do see how the black hole influences the way that the other star moves. The gravity of the black hole influences the movement of this other star, and this is how we can see them. And also when they are torn apart, if some star gets too close to the black hole, the gravity which is closer to the black hole is stronger than the gravity which is, further away. And this star starts to rip, and the particles from that star are going into the accretion disk, which goes around the singularity. And this is very, very hot, so it radiates, and this is what we can see.
So this is mind-boggling stuff right there. It's hard for us to understand. It's like going
Yeah.
singularity, and I mean, it's like you don't know can scientists kind of predict, or at least from theory perspective, what's going to happen once you're going to be sucked inside the black hole?
There are a lot of theories. I mean, you know that since in the 2019, we only had this first image of a black hole taken, and only in this year we had the Nobel Prize for actually, seeing black holes. So the theory was done in the 60s by Hawking and Penrose, and we knew that. I mean, they used general relativity to predict that they are inevitable, and this theory was confirmed by observation through, I don't know, past 12 years, I think. It's not something that happened overnight. And this Event Horizon Telescope, which did the first image of a black hole, it was also an initiative which they took, I don't know, 200 countries, I guess, a lot of people anyway. So it's not easy to know what's going inside because we cannot really approach it too close. We can see what it's doing to other stars and what it's doing to the surrounding, but we cannot really approach it. So it's difficult to say what would happen if we cannot really even see it, basically,
Yeah, yeah. So what do you think? Again, because part of that, as I mentioned, 2020, we're talking about those three Nobel Prize winners who achieved the Nobel Prize for finding the black hole in Milky Way. So, and when we're talking about, black holes sucking in, the stars itself. I mean, if it crosses the path, of a black hole. So should we be afraid of those? I mean, if it's there, we know it's there, and it's probably a couple of them, or maybe more. Who knows? Because the galaxy is big enough. But should we be afraid of those black holes that are out there?
I don't think so. Maybe I'm wrong, but I don't think so because if you imagine our solar system, right? And we have a star in the middle, it's sun. And if we took away the sun and put black hole there, but the black hole would have the mass of our sun, nothing would change. No, really, actually nothing would change because if the mass would be the same, it's not really possible, or we didn't find a black hole which is the mass of the sun because it's impossible. But if it would be possible, let's theorize for a moment that the black hole is the mass of our sun and we put it in the center of our solar system, nothing changes. The gravity and the orbits, everything is the same, So if the black hole is there and it's been working so far, I don't think it should, change anytime soon. Maybe someday, but not in our lifetimes and in our kids' lifetime and so on and so on.
Got it. Okay, so there's some hope for us,
Yeah.
There's some hope. Hopefully, I mean, there's a lot of those different things involving. Again, there's a lot happening in universe, right? All the different physics, because there's completely different physics factors applied to black holes, and I mean, there's all these events happening, not just with asteroids, with exoplanets. Of course, we should talk about as well. But yeah, so hopefully. So what is your personal approach in multiverse theory? Would you think that something is out there again? Because some of the people are saying that once you're going to be sucked into black hole, maybe you will come out at the end of the universe. I mean, it's going to be completely different. So what is your personal take on that?
This is actually interesting question. I asked myself that a lot of times, and my friends, what do you think? Is the black hole like a tunnel to the other dimension? I don't know, but it is a nice thought, right? If we would make it possible to go inside a black hole, what would happen? Is it like Interstellar, where we have this, room of strings and see all the time, looped around us and we can choose wherever we go? Or is it just another universe? I don't think it's possible that there is another whole other universe. It's more likely to happen, I think, that we end up in the other part of the universe, our universe, than in the completely different one. I don't know, maybe it's too realistic of an approach and it's not good maybe, but I think we should first focus on, if we want to know how to get close to the black hole. And if we ever wanted to get close, we would have to achieve the speed of light. And this is our known limit. This is the axiomat we cannot break and we shouldn't try to break because everything will fall apart, all we know. And yeah, if there would be ever a day that someone discovers, the fuel or the propulsion to achieve the speed of light, then we can theorize what there is.
Yeah,
Let's leave it for the science fiction for now.
That's it. Let's leave it there. But hopefully people, again, just like those people who are detected black hole in our galaxy, hopefully there will be more people involved into doing research on those things, because those things are very science fiction like, I guess, because we don't know what's the on other end of black hole. And again, we're talking about completely different physics that will make an impact, let's say, on our personal body and on probably on the materials that we have on Earth. And we probably, if we will go through that, probably because of the different gravity and just the like physical things that happening there in the black hole, probably we will become some sort of a, I don't know, just a goop, just whatever.
Yeah,
So
like spaghetti.
just yeah, so we need to find out. I mean, how can we do those things? How can we explore the black holes? Because I think it's a very interesting topic. So, but what are the things? Because I'm sure I'm not asking you a bunch of things about the black holes, but you kind of mentioned we need to talk about that. So, what do you think is the one thing or a couple of things about that people should know about black holes?
There are these theories, dark matter. We say that it universe is mostly contained of it, and this is the only way how we can explain what is within the dark spaces. And there is this theory that black holes, that the dark matter may be made of something similar that the black holes are made of. And this is extremely interesting and really difficult to observe. When we discovered gravitational waves, we thought that, okay, maybe we can use this to explore what the dark matter is made of. and not really, because we have this map of universe, WM map, which is the map of the known observable universe, and we have all these points and spots with the stars and all the radiation, and we can see even the galaxies that were made just after the Big Bang and stuff. And this is a contradiction to what we thought about dark matter and black holes, because it would be visible, we would see that. But again, there are some experiments that point out to this kind of theory. And this is something that blew my mind lately, and I'm kind of obsessed, because what is dark matter? This is so unknown and so interesting that what is that? I mean, it takes out most of the space and we still don't know what is it. And there are two theories that are making the most sense. It's the black holes, I mean, the material of black holes, and the other subatomic particle we have yet to be discovered, that we have bosons and electrons and protons and stuff, and maybe this is something like that.
Yeah, so
Yeah, I think it's nice theory, but far away from that.
yeah, it is. I mean, it's again, it's another mind-boggling, topic, which is dark matter. And again, because when we look at the space, we kind of, okay, there's planets, there's all these objects moving, but where we are in this dark matter, I mean, what's happening with that, So, because one of the questions I remember I asked one guy a long time ago, and he was about to pursue his personal career. He was studying rocket science, and asked him a question. I was like, look, can you explain to me, I mean, where we are, And he was like, look, we are in like this position wise, we're like in this and that. And I'm like, no, look where we are. I mean, what's happening? Because I know, look, universe expands at the rate of the universe. And, it's while we're talking, I mean, it's happening at an insane speed, But at the same time, where are we placed? I mean, if we imagine the universe, I mean, where it is, because we have our own perspective. I'm in the room. The room is besides that is a house, and beside the house there is street and people walking around it. So, but what is a personal perspective? I mean, what do you think is all this placed in?
This is a really difficult question, because as we know, universe doesn't have a center. We have all this universe which is expanding, like you said, at the rate that is expanding, but we don't actually have a center. And the most common and good analogy is with the balloon. If draw the stars on a balloon and you blow it, then it expands. But this is also not actually correct, because the galaxies and the stars are not, stretching. They are having bigger distances between one another, but they are not stretching. And we cannot really say where the center is. I mean, even the Big Bang, it wasn't a place where it happened, because in order for having a place for it to happen, we have to have a place where it
Yeah,
happened, and it
yeah.
didn't. The burning of the universe didn't happen in. If you want to talk about place, you can say that it happened everywhere at once, not in one place. So if you don't have a center, and you don't, as you said, we don't have a perspective, like in a room, it's impossible to say where we are, because yeah, the observable universe is a sphere, sure, around us. You can say that we are in the center and this is a sphere, but this is the observable universe, not the actual universe. So it's impossible to answer that question. I mean, everything is impossible to be located without perspective.
Exactly. At least for us. At least for us. Because
Yeah, at
I
least
mean,
for us.
yeah, it's a very big topic, because we get scientists and people, and I do appreciate those people so much, again, as the people who won the Nobel Prize. And I'm sure there will be many more people like that to come, and they will make groundbreaking research, and found some amazing things that will be located in Milky Way or somewhere, again, exoplanets and different things. I mean, there are billions of different galaxies, and there are billion different things that will be discovered, hopefully in the near future. But sometimes those people sit down and they try and explain with a theory, which, look, at the same time, where those people go? Those people are born, raised with the families. They go to school that are made by us. they read the books, but that are written by the people. So we need completely different information to understand those things, you know. And sometimes we assume we make, you know, smart, you know, we make a kind of intelligent talk, and we try to explain, you know, to the people what that means, but we don't know. Like, we don't know what's happening. Like, sometimes, most of the time, we're just clueless because we never left the solar system ourselves before, so we just guessing, you know.
And you know, our view and the way we understand things is, you may say, polluted by others people thoughts. As you said,
Yeah.
the books are made of other people, by other people, and someone with some theories we already know written them. So I think Elon Musk was the one who said this beautiful thing, that if you want to create something new or discover something new, you have to get away from all the things that people are talking about the trends. As you
Mm.
know, for example, black hole or something, we have a few assumptions of how it how is it born, and how is it made, what is it made of and stuff, and how it will end. And if you want to create something new, new theory, you have to get away from all that and focus on the basic physical phenomena. You know, just start fresh, observe it, and
Hmm.
draw the basic conclusions, and then try to explain how is it work. And when you have some new observation and you think this is that, this is a black hole, then you should try to explain it in every other possible way, just to make sure that this is not something else. There were a lot of observations, like in the 90s, I think. We thought that we discovered aliens, you know, other life, because we have this pulsating light coming
Hmm.
towards us from the space. And we thought, oh my God, the nature doesn't have the periodic responses like that. This has to be other life trying to communicate with us. And then after making a big fuss in the media and stuff and drawing the papers, this is the
Hmm.
life, we're trying to communicate with it, some physicists like sit down and thought, okay, but maybe this is something else. And
Hmm.
then bam, we discover neutron stars and pulsars. You know, maybe not the neutron stars were discovered there, but you know,
Hmm.
the this is the observed pulsar, not
Yeah.
uh, you know, foreign life. And this is the same that goes for every other observation and experiment and theory. And if you want to do something new, you have to sit down and look at it from various perspectives, not only what people are telling and what the trends are. Just
Yeah.
as it goes in the films, it's no different from reality. You sit down and you have all this data and you analyze it, and you start over and over and over again until you get something.
Exactly, exactly. So you know, so again, at the same time, these people, all of these people are awesome. Again, because look, personally, I don't have a physics degree or, you know, fancy PhD or something else that I can do some sort of a research. And again, I'm trying to add value to my own personal, you know, projects and things like that. But you know, it's just as you're saying, you know, starting from blank page. Of course, you need some sort of understanding what's happening and the way universe works, but then you have to add kind of your perspective and start fresh, because again, if we just follow, and we need to follow what other people are accomplishing maybe, and because like I had some people on my show who are doing some really important PhD work when it comes to, you know, physical bodies and the way it react long term when we are in space in a zero G's over long periods of time. But he said, you know, I'm not sure if I will be able to kind of uncover and unveil everybody to the people in my personal life. So there will be all this work left behind this man, and somebody else will come in, will observe, read through it, and say, okay, no, I think it's completely different or something else. And it will continue from there. It could be that, or you could start your own personal research yourself, you know?
Yeah,
So,
there are a lot of theories that, I mean, just like the very popular one, the general relativity, there was Einstein who thought, okay, maybe this works this way, the gravity is explained like this, but the curvature of space-time, and he didn't know much about a curvature and curves generally, and this whole uh, Riemann algebra, because
mhm,
he was no mathematician. And then he thought, okay, I have a friend who just did a PhD on curves and all this other part of algebra. And they came together and they talked and they exchanged thoughts, and bam, we have a new theory. And in all physics, it's not something you can really do alone. It's not like you hear about Newton and Einstein and you think, okay, this is a one-person job. It's not. Even they didn't work alone. And in modern physics, you never work alone. I mean, you do some part of your work alone, but this is always these huge collaborations that are taking place. And, the Nobel Prize can be given only to like 3 people. And so many of the people who I think deserve it don't get it because they work in this huge projects. And this is how physics is made these days. This is how discoveries are made, not by one person. Those projects often last more than 10 years sometimes to discover something and to describe. And we sometimes have a theory and we think, okay, there may be another planet in our solar system. But if there was nobody that spotted it so far, it has to be so dim, but so small and dim that you won't be able to do that like conventionally. So you have to first develop the theory and the mathematics of to pinpoint the place where you should find it, where you should look, and then spend years and years of looking in this one particular place to find it. And this is how the physics sometimes work as the reverse analogy. You don't always observe something and describe it. You very often describe something and then observe it.
Mm-hmm. That's it, and that's a very great advice right there, because everything which you're saying is a teamwork. Even though we sometimes assume that just one person did that. When we think about Neil Armstrong being the first man on the moon, we don't think about him. I mean, there's all this NASA scientists and engineers and physicists, astrophysicists. I mean, a lot of people, probably thousands of people who got involved with that. So it's same with Albert Einstein or different people who are involved in different science projects. Exactly the same. So I love what you're saying, that because I talk about that all the time: collaboration and bringing more people together for the same causes. So the last question that I have for you for about the black holes, because again we have our own star. So what do you think personally, where there will be a time where our personal star sun will become a black hole at some point?
It's not possible. Our sun is destined to become a white dwarf, and this is due to its mass, its density, the matter it's made of. Like I mentioned, black holes, different type of mass. It's not the same range. Our sun, it's actually other stars are often compared to our sun because this is our sun. We know about it. We can explore it. We can observe it. So it's often as one solar mass, and our sun is one solar mass. And in order to something to become a black hole, it has to be at least, I don't know, 1.5, I think, solar masses after the fuel is over, after the star is cold star.
Mm-hmm.
So no, there is no possibility. We know for sure that our sun will become a white dwarf.
So, what do you think the time frame is? I mean, I'm sure scientists putting a number on it until it will become a white dwarf. Like, what time frame are we talking about?
What time? Oh, this is very, very long time. Like
A billion
I'm
years?
yeah, something maybe. I'm not sure, but yeah, very, very long time. Not something. I think that it's more probable that we as a human race will either explore different planet to move, or we go extinct of some different completely unrelated kind of reason, then our sun becomes a white dwarf. It's no, not possible. I mean, we have also this zone that is called habitability, and when we have sun and other planets, this is the like in 2D a place where planets have this distance from sun where they can have life. Let's say our life as we know it, at least, that the temperature is not high enough or not low enough to have fluids, have water in the liquid state and stuff. And I think, I'm not sure, but I think that we will be first drawn closer to the sun and out of this habitability zone, then the sun will become a, white dwarf.
Hmm. So what do you think? Even though I mean we're talking about billion years, which I mean it's a billion plus probably years. I don't know, but we're talking about very long time. Nobody, none one of us was gonna live that long to see those events happening. I'm sure that future generations will. But what do you think is your personal take? As now again in 2020 we're looking towards Mars exploration and colonization and building a moon base. So, but at the same time, in the long run, I mean, we're still going to be in the same solar system with the same white dwarf if we're going to do that. So, but my question on Mars colonization, do you think is going to happen soon? Again, Elon Musk talking 20 years, not 40 years. And why do you think it's good for us to go and explore Mars?
I think it's very, very important to explore other planets, not only for the purposes of actually knowing what's on the other planets in solar system, but also, if you want to go somewhere, you have to develop the technology to do so. And this is the perfect opportunity, not only to get samples to see what's there, to see maybe different materials, different life forms, if we find any, and different kinds of structures and matter, but also to develop the technology which allows us to go there. And this is extremely important because if, as a humans, we want to be remembered, we want to survive, we have to leave the solar system. We have to colonize at least one other planet. And not only, we have to leave our galaxy to become, to have our impact, to have the place in the history. We have to do this. And not only solar system. I mean, most of the people don't realize sometimes, maybe not the people who are watching this because they are interested in astronomy, but if we look up, we see a lot of stars, right? And our solar system has only one star, Sun. This is maybe sounds absurd, but it's not that absurd. If we look up and we are younger or don't have the knowledge, we think, oh my God, we have so many stars. And no, we have one star. And we have to go further and further to become, the multi-planetary, let's say, population, and then multi-galaxy, and so on and so on. So it's important to colonize other planets in order to colonize other planets and other galaxies and other systems, let's say. Yeah, it's very
Mhm.
important. I think we should primarily focus on this and simultaneously at researching the space around us, so we know what is waiting for us. What
Mhm.
types of dangers and maybe. Yeah.
Got it. So I'm looking at official's NASA website. You can go to exoplanets.nasa.gov, and you're gonna find a list which it says exoplanets and 4,306 currently confirmed, updated
Yeah.
yesterday, and potential candidates 5,682. So again, planetary systems 3,196. So we're talking about big numbers. So what do you think about exoplanets and potentially us living in there at some point? I mean, how doable is that for us again with the current technology? Because again, one of the things that we're missing out is propulsion system, and now scientists are working on kind of nuclear powered propulsion systems. So when do you think it will be possible to us actually physically or through robotics explore these exoplanets?
It's hard to say because sometimes the discoveries happened from day to day, let's say, and overnight, and not overnight like they're confirmed overnight on or explored, but the ideas happened overnight sometimes. And for now, it's impossible, and we won't be able to move beyond because the fuel, right? It ends at some point, and in order to go up and stay up and go further and further, if with some mass, with people and with equipment, you have to have a lot of fuel, and this is not the type of fuel that we have yet that can do this. And like you said, the propulsion, this is important. So now it's hard to say, maybe like Elon said, 20 years, maybe 30, or maybe even sooner, because as I said, between the idea and the actual doing this is a long path, because we can have an idea how to do that, and we can have an idea what type of matter can do this, but experiments, they take the longest because we have to be sure that this is safe, that this will work, that this won't be even worse than if we didn't do that. So yeah, I think at least 10 to 20 years. Yeah, I would say at least, because even if we have power plants and stuff before, if we have the technology, and we have the technology to make power plants, and we have the diagnostician system and everything, it's still is going to take us at least 10 to 15 years before we have actual power plants running. So, what just compare to going into space? Yeah.
Yeah. So, well, at least it's not going to be, hopefully, it's not going to be 200 or 2000 years until we're going to go and do that. But is there physically that scientists can now observe these exoplanets and kind of look at what's happening again, let's say with measuring, let's say temperature or conditions in those, exoplanets, so we can kind of make our own personal decisions, even if it's worth going right there, and exploring that planet?
Yes, we are observing other planets, but not in the conventional visible way. We kind of do that in order to live in on some planet, you have to have water, right? And some other uh, life forms, maybe carbon or something. And those give prints, and carbon and water, let's say H2O, we have we have to have some other elements that either show that the water was already there, either show that the water can be like made out of this in some specific conditions. And we also have to look, as you said, as the temperature and the atmosphere and stuff. I mean, the atmosphere, I think it's the problem we can deal with, but the water and those elements, no, definitely we have to be able to make or draw, or I don't know, do something to get water. So if we explore other planets, and I mean, explore, too much to say, but we observe other planets, these exoplanets, we look for the traces that some elements are where or will be there. And this is the most important, to see if the planet is like, will be able, if we will be able to live there. Those elements have to be there, and we can look for them in different source of radiation, to sending them and receiving them. So this is the basic stuff.
Got it, got it. So, I mean, talking about that, if we're talking about the elements for potential habitable places, again, if it includes water or some of the elements that could be found on the planet, to make sure that we can go and actually live in those environments, are we talking about possibility of some other life form in those exoplanets as well?
Our universe is so big that I think it would be extremely egocentric to think that we are the only living form, the only forms of living to in this whole universe. I mean, maybe it's not the life as we know it. Maybe it's something completely different. It works differently, but we would be able to label it as alive. And I think definitely there are other forms of life in the universe.
Mm, got it, got it. Well, definitely, there's again, if we look at the numbers on all those billions of probably trillions of galaxies, and again at the same time, universe expands, and there probably maybe another big bangs are happening at the same time while it's expanding. So we're talking about endless possibilities, right? But
Yeah, the simple
yeah,
probability, right? You have those numbers of universes and only one life form.
mm,
It's not mathematically accurate,
waste of space, right? It will be waste of space
Yeah.
for someone else. Yeah, good.
Yeah.
So what is a personal? I mean, I don't know how much are you actually doing personal like research, because you mentioned you can only be good at, let's say, one or maybe a couple things maximum, right? And can you talk about maybe some future, space projects that you're looking forward to? Maybe not a lot of people know that, and maybe you would like to share some of these.
So I'm thinking about maybe joining ESA someday, maybe as an intern first, and then maybe
Hmm.
work there. And there are a few projects that are really interesting for me. One is the idea of mega constellations. You can look it up at the ESA site. It's the problem that we have a lot of different equipment out there and orbiting Earth and stuff.
Mm-hmm.
And all of this emits light. And
Mm-hmm.
this light can distort other measurements that we do, like the Hubble Space Telescope and stuff. So this is the important thing that we never thought about. Like we thought about cosmic waste and how to get rid of this and that, but we never actually thought about the light we emit. How does it influence the measurements we do in space? So this is the project that I'm interested in. I cannot really talk about more about this because I still know. I know that this exists, and maybe how they do this, they take data from different telescopes over a few years and they analyze it through very thoroughly, and see how it changes. Different projects is the ESA has this amazing robotics center, which work on human and robot interactions, the interfaces, and how to build maybe some vehicles to explore other planets or stars and stuff. And third project I like to mention is exploration of moon, because I myself, I am in love with the idea of moon and with the moon. I think it's beautiful. I love to observe it. I never miss a full moon, and I love to observe those photographies of astronomy. It's beautiful. I love it, and we have to explore moon as well, because if you think about it, this is kind of close, right? The moon, and we still don't know what is beneath the surface, like actually
Mm-hmm.
like try at it. And there are projects that work on the vehicles and the whole energy balance, how to make it happen, to send the vehicle there and get some samples maybe and go back with it. So there are many interesting projects, but if you think about it, we don't really know what it's beneath our feet either, right? we
Yeah.
we are exploring different planets, but we don't actually know the whole surface, like the bottom of the ocean, and we don't actually know what is inside of the Earth itself. And it seems ridiculous, but it's actually not that ridiculous. It's hard to look down.
Yeah, exactly. So I had somebody not long ago on the podcast, and they talking about exploration of caves, and that person couldn't say the specific again the details because it's been they found those kind of species of animals of that are they thinking of going extinct, and again those species were found deep in the caves, and again they can talk about location and. So basically that is happening, and they talked about basically that person
Yeah.
also talked about bacteria that's been found that could cure some of the diseases and can become let's say used in medicine also. And the way those, because again we're talking about nothing, just a rock, in the cave, and how those bacteria survive, they actually eat the rock, so we're talking about some stuff
It's
that
just
we
insane.
yeah, that is insane. We're talking about the stuff that we never heard before, and we still have so much more to, as I mentioned, to explore here on the planet. Because I think it's very small percent of what we actually explored here, as well. Because the planet is pretty big, it's pretty big. So there's a lot of things still to be explored. So yeah. So again, I mean, I love it. I love it. I love the fact that you're looking to work from for ESA or NASA at some point again, and you're applying for those. So again, hopefully somebody, as I mentioned, maybe somebody will see that, because I love your personal enthusiasm, passion behind it, and
Thanks.
I love the fact that you, again, what you said, it's so true. Instead of diversifying your personal time and attention to all these different things, because there's so much happening in different industries across the space exploration, so just focusing on a few things, one thing, which is awesome. So what is your personal kind of legacy that you want to leave behind you as well? Do you want to leave some sort of a footprint that people will remember you by?
I mean, I was never like gaining attention and maybe followers or something like that. getting my name remembered. Sure, everyone fantasizes from time to time when they're in physics that you like invent some theorem, like NIKOLA theorem and stuff. Yeah, but sometimes, but mostly what like I want to do is make a change, I think. I mean, I want to in 20, 30 years, I want to say to maybe my kids that, yeah, I did something. I participated in this progress. I was a part of bigger system that made this and this happen, that we know about this and this because I helped, yeah, something like that.
Yeah, good. So that's what it is. I mean, it's everybody they ask the same question. Everybody kind of has the same answer as you have. So mine again, it would be exactly the same because we don't know how much we can do, and again, we can do so much more if we just put the forces together, and accomplish great things. And again, I had more than a few people on the show who are from Poland, and Poland is actually putting a lot of attention and putting people
Yeah.
together, and there's a lot of different things that are happening right now in Poland when it comes to space exploration projects, Mars colonization projects, moon bases, and traveling to. So it's awesome. I love what's happening down there as well. So for you people who are watching this episode or listening on the podcast, make sure to first of all get in contact with Nikola herself personally and ask those questions, because I'm sure, I mean, there's many more questions that we can, that I can, ask you, and different subjects that we can talk about. But,
Yeah.
ask those questions. Go in contact. If you're looking to get started, let's say maybe you want a degree in physics, ask her about that. You can work about different stuff, and maybe we can, work on some future projects together, because that's what it's all about, bringing people and, attention and the time and the resources together so we can accomplish these things faster. It's all about that time frame, it's all about that. And the last thing that I wanted to ask you guys, if you share this episode to your friend, it could be any friend, make sure to pass this episode along, because I mean, there's a lot of great information, black holes, what we talk about, exoplanets, future possible lives, and those exoplanets, and discovering things in universe and exploring planets, and I mean, a lot of great stuff. And I'm sure a lot of it will inspire those people to pursue their own projects. So make sure to do that. So Nikola, for you personally, a big thank you for coming over today and sharing your personal journey, passion, and of course, how and why people should get involved with space exploration projects. So I appreciate that.
Thank you. It was fun.
Thank you. Thank you. So guys, again, make sure to share this episode. And as always, I'll see you next time. And don't forget, keep exploring.